Alright, welcome back to another day. Today we're going to be doing diagonal difference, and this question is asking us, given a list of numbers, they want us to calculate the difference between the sum of this diagonal and the sum of this diagonal. So the first diagonal is going to be 1 plus 5 plus 9, and the second diagonal is 3 plus 5 plus 9, and then we get the difference between the two of them. And then the absolute value just means if the difference is, if you do the subtraction and it's negative, just take the positive anyways. Okay, so if you've been following along my HackerRank series, this is going to be the first time that we're going to be interacting with lists and a list of lists. So let's go into a little bit about how those work. Okay, so a list of lists, well, first, a list we can just think of it like an array. It just contains a list of numbers. And in this case, our array here is a list of integers. So it looks like, a big list, and then 1, 2, 3, and then another list, 4, 5, 6, and our third list, which I believe was 9, 8, 9. So in previous videos, I showed that if we want to read, a value from an array, we had to do something like this. Now this works if it's a primitive array, but since this time we're dealing with lists, instead of this, what we're going to do is a function call. So if we do something like r.get 0, we'll get the 0th index, which is 1, 2, which is a list of 1, 2, 3. If we get 1, we'll get 4, 5, 6, and similarly for 2, we will get 9, 8, 9. Okay, so how about getting a number from inside one of these? So what that'll look like is if we say r.get 2, we get into this list. To get one of these numbers, we can proceed with, for example, get 0. This will give us 9. If we do 1, this will give us 8. If we do 2, that will give us 9. So that's how we're going to be accessing the data in this array. Okay, so let's get to the main question part, which is we want to figure out the diagonal. So we want to figure out this, this diagonal, and we want to figure out this diagonal. Okay, so let's see what values we should be reading in this case of 3 by 3. So in here, we're going to be reading basically get 0, get 0 would give us our first value of 1. So for simplicity, what I'm going to do is let's call this our row, and let's call this our column. So that gives us 1, and here we actually want to read 1, 1. So we can see that our rows, just erase this, our rows are here. So these are our rows. These are 0, 1, 2. And these are our columns, which also has 0, 1, 2. So 1, 1 gives us 5, and 2, 2 gives us 9. So if we add all of these up, this gives our first total of 14. So if we add it all up, we get our 14. Now you want to do the other side. So what will this other side look like? Let's see. We also have our row and column. Except this time, when we have 0 here, we want to read the second one. 1 here, read the 1. And then 2 here, we read 0. And that will give us 3, 5, 9. And this added together we will get 14, 17. Okay, and then finally, to finish the problem, we just have to find the difference between the two. So 14 minus 17, that'll give us, well, this gives us -3, but with the absolute value around it, we'll just return 3, and that's the number we'll return. So now we have to start noticing some patterns that we can use to code this, because right now we can easily see 0, 0, 1, 1, but how do we tell the computer? So in this case, we notice that every time the row is equal to the column, that's when we add the count. Now in this case, we have our row incrementing this way, while at the same time our column is actually incrementing this way. So they're kind of exactly the opposite. So let's look at the first case. The first case should be pretty easy. When we're scanning by zeros, we'll just make sure when we're scanning each row, we want to add the same index as the row. So when we see row 0, we add the column 0. When we see row 1, we add the column 1. See row 2, we add the column 2. Now, what about for this one? This one, it seems like we always want to go for the opposite. So how do we figure out 2? Well, 2 is the last number in our first array. So if L is the size, so in this case, L equals 3, because this is a 3 by 3 square matrix. We actually want here to be, let's try drawing it this way. We actually want this to be L minus 1. And then here, we want 1, 3 minus 2. We actually want L minus 2. And here we want L minus 3 to get us our original of 2, 1, 0. And now we have a function that can give us the column given our row. So given our row, to get our column, it would be 0. So if this is our row, we would get L minus row plus 1. Right, so if we have 0, that gives us 3 minus 0 plus 1, which gives us 2. If we have 1, we get 3 minus 1 plus 1, which gives us 2. 3 minus 2 equals 1. And finally, with this, we have 3 minus 2 plus 1, which gives us 0. So I think now we figured out our two equations that we want. So one is row is the same as column, and the other one is row is the same as our size minus row plus 1. And now we can figure out our two diagonals. So let's try coding this up, and then I'll go into one more optimization that we can do at the very end. Okay, so for coding this up, what we can do is we can have our first diagonal, and our second diagonal. I'll show you at the end how we can actually combine these two, but for now, let's just do two diagonals. So to loop through, we'll do the same thing as before, int I equals 0. Now how to get the length of the array, we can do array dot. Well, when you're not sure of things like this, what you can do is you can actually Google it. So in here, we can go Java list, and there's usually a site that'll tell you exactly all the methods you can call on this. And the one that we're looking for here is size. Return the number of elements in this list. So here, as long as it's less than size, we'll go one bigger. And now we're reading each row. So what we want to do is we want to add it to whatever it was before, plus the one that we're looking into is array at the ith row at the ith column. That'll give us what we want. So if you want, we can do plus equals here and get rid of this duplication. Okay, and that should give us our first diagonal. So for our second diagonal, what we want to do is we want to add it to our array at this row. But what about the column? The column that we're interested in, if we go back here, is actually the size minus whatever the row is plus I. So here it's going to be get what the size of our array is minus minus our I plus 1, and let's make sure we have our brackets right, and yeah, looks like that's correct. Okay, and then at the very end, what we want to do is we want to return the absolute value between our first diagonal subtracted by our second diagonal. All right, let's give this a go. Oh, and it looks like our expected output is correct. Okay, so let's see how we can make this a little bit better, because we can actually do this all within one loop. And the thing we're going to notice here is, I'm going to select everything and let's just remove this stuff, remove this stuff. Okay. So what we can notice is what we're doing is we're going 1 plus 5 plus 9, which is our first diagonal, minus 3 plus 5 plus 9, which is our second diagonal. And let's see, what happens if we take off the bracket? So we have 1 plus 5 plus 9. The negative goes in, so minus 3 minus 5 minus 9. And then, we have our absolute value here, absolute value here. Now what I can do is, you can see this is from the first row. This is from the second. And lastly, this is from the third. So we can reorder this into 1 minus 3 plus 5 minus 5 and 1 minus 3 plus 5 minus 5 and then plus 9 minus 9. And this is from the first row, this is from the third row, and this is from the second row. So if you see where I'm going with this, is that when we loop through the first row, we know we can just add this, subtract this. Go to the second row, add this, subtract this. Go to the third row, add this, subtract this. So in here, what that'll look like is we can output just have one diagonal here, in diagonal. And then we will have our diagonal plus equals our first diagonal, and then we'll minus it with the value from our second diagonal, which is this guy. And then at the very end, we'll do the absolute value again, just like before. Let's see. Diagonal. All right, let's see if this still works. Run our code. Okay, looks like it still works. So what we've done is we managed to get rid of 2 loops over it, and we just have 1 loop where we do the both of the diagonals calculation. Now all right, looks like everything passed, and I'll see you guys on the next day.